Right. This is going to help you, I think, understand HO and HA a little bit better. And we're going to start off with HO. And it's the same example in the book. So this is just going to reinforce what I wrote in the book. Or if you're watching this first, you'll understand what's written in the book a lot better. So just a cute little FYI here. These are my two adorable children when they were young. That's my youngest, Troy, and my eldest, Burgess. And I think they were about 3 and 5 when this was taken. And trust me, they were only playing, but it kind of looks like Troy's about to karate chop Burgess. So I thought this would be a great picture to include because we are testing this hypothesis, or this research question, I should say. A hypothesis is not a question, it's a statement. And this is a question mark, so we're going to look at this research question, and then we're going to go over the two hypotheses that are going to be pitted against one another, much like the two boys were pitted against each other here. So the research question is, will watching violent cartoons increase aggression in 4 to 6-year-old boys? He's 3, but he looks 4. Okay, so this is a concern for a lot of parents because there's all this research, which is actually quite controversial. But there is some research to suggest, hear that term, right? Suggest that there could be an effect of watching violent video cartoons in terms of aggression. Okay, young children becoming more aggressive. So, HO, remember the symbol is HO, is going to say that the mean for population 1 is the same as the mean for population 2. So this is going to make more sense when I show you the next little thing that I'm going to pop up here. But just remember that saying that two means are the same is saying null, not a nothing, right? These two means are equal. You have nothing there. So we'll come back to this. Okay, so actually this popped up. I should have had the graph pick pop up before this. So I'm just going to bring that graph up right now so you'll understand the procedure. Okay, so we're going to start off, in order to run this study, we're going to start off with a population. And you, as the researcher, get to define the population. And we're going to say, well, it's the population of 4 to 6-year-old boys in the United States. Okay, fine. That's your population. Or you might define it as 4 to 6-year-old boys in Utah. It's up to you as the researcher. But regardless, you define your population. The next thing you're going to do is you randomly sample from that population. All right, so you're not picking and choosing people. You're randomly selecting people from the population, in this case, the young boys. Now, you learned at the beginning of the semester that what we call random is really convenience sampling. So you don't have access to all the 4 to 6-year-old boys in the United States, but you have some access to those in your community, and then you can randomly sample from among those you have access to. So in your community, you randomly sample 4 to 6-year-old boys. Now, once you've randomly sampled from your population, then you randomly divide them up into one of two groups. All right, so group 1 is going to watch a non-violent cartoon. Winnie the Pooh, I think, is a great example because the most violence I ever remember seeing on Winnie the Pooh is bees chasing Winnie the Pooh for stealing their honey. All right, so that's about as much violence as you're ever going to see in Winnie the Pooh. The other cartoon, though, is Tom and Jerry, and I have seen Tom and Jerry get fairly violent with each other, hitting themselves over the head with baseball bats and stuff like that. So this is pretty violent by young children's standards. Okay, so again, you're going to randomly assign the boys, to one of these two groups, And just as a review, that makes the video type, that makes it a true independent variable because you're randomly assigning the boys to the different groups. So a true independent variable, so we have a true experiment here. Okay, so they're going to watch their video, let's say for 30 minutes each, and then you're going to set them all free onto the playground, and you're just going to count the number of aggressive acts committed by each child. Right, so there are some ethical faux pas in this experiment, but we're going to ignore the ethics right now because this is just a thought experiment. All right, so these Winnie the Pooh kids, they're out mixing and mingling. We count the number of aggressive acts by each child, and then we get our sample here. Okay, so we're looking at this mean here. The mean 1, x bar 1, would be the mean number of aggressive acts in our sample. Some of the boys were not aggressive, but others were, and this is just the mean or average number of aggression. So our measure of aggression. Same thing here with the Tom and Jerry boys. We're going to count the number of aggressive acts by each child, and again, there's going to be some, very low aggressive children, and then there's going to be some high aggressive children, and this is the mean number of aggressive acts for this group. All right, so x bar 1 refers to the non-violent cartoon, and x bar 2 refers to the violent cartoon. All right, now remember, what is HO going to say? HO is going to say that the two population means are equal. So where do we get these two population means? Well, x bar 1, remember when we looked at descriptive statistics and the first, 6 chapters, we talked about how x bar is an estimate of mu. So that means x bar 1 is trying to estimate mu 1. And then x bar 2 is an estimate of mu 2. So these are all, x bar 1 and x bar 2 are just estimates of what's going on in the population. And according to HO is saying nothing is going on. Your mu 1 is actually the same thing as mu 2. All right, there is no difference between them because this manipulation did nothing. All you have is one population of 4 to 6 year old boys, and you might have tried to treat them differently. And it could be that, yes, you're going to get 2 X bars that are different, but in reality, these 2 X bars are only different because of sampling error. All right, so if we look at this group here, this X bar 1, let's say, is equal to 3. And let's pretend x bar 2 is 13. So according to HO, we would expect to see 2 sample means are different from each other. Why? Because of sampling error. What does that mean? Well, according to HO, maybe these kids scored really, really low, not because x bar 1 is estimating mu 1, a separate population. It's because these kids here happened to come from this part of the population. In other words, they were very low aggressive children to begin with, and they just happened by chance alone to end up in the Winnie the Pooh group, which again resulted in a low aggression score. But it's not because of Winnie the Pooh, it's because they just by chance came from this part of the original population. And according to HO, x bar 2, we said what, 13? X bar 2 is different from x bar 1, so x bar 2 is considerably higher, but not because they watched Tom and Jerry. X bar 2 is higher than x bar 1 because these kids just happened to come from this part of the population. So in other words, they were the most aggressive children to begin with, and they just happened to end up in this group. All right. So HO is going to say that, you might think that X bar 1 is estimating mu 1, and you might think that X bar 2 is estimating mu 2, but you really do not have two different populations. They are equal because they are actually one and the same. These two groups are two samples that are representing the same original population. It's just that one happened to come from this end, the other came from this end. This manipulation here had nothing to do with it. And HO is always going to stick to their guns. Oh, that's a good stick to the guns, right? Aggression, right? Anyways, okay, so HO is always going to say mu1 equals mu2. If we're comparing two sample means, it's going to say there's no difference in the population. Null, nada, nothing. Anything that you saw in your samples, because clearly we saw something. This is 3, this is 13. We're seeing something. Yes, we're seeing something, but it's because of sampling error alone. All right? Aggression in boys in the population, we would not see any difference between kids watching either type of video. It doesn't matter. There is no treatment effect. Null, nada, nothing. Now, because we're using hypothesis testing, which means we're using samples and we're trying to figure out why they're different, we have to use the word probably in our conclusion. So if our data isn't strong enough to reject HO, isn't strong enough to refute it, then we're going to have to retain HO. We're going to have to keep with it, but we're just going to conclude that it's probably the case that watching a violent or non-violent cartoon has no effect. Okay, so don't forget that word. Now that's HO. What about HA? HA is going to say that your two population means are not the same, that they are different, and that means there's more than just sampling error going on. So how does that work? So again, I'm going to put this all up here. Okay, so let's focus on this. This is a refresher. We start off with the population. And from this population, we are going to randomly sample, with the quotation marks around random, because it's really convenient sampling. But we're going to accept that loose definition of random. So we randomly sample from this population. And then we're going to randomly assign them to one of the two groups. So half go here and the other half go there. Remember, that makes the type of cartoon a true independent variable because we randomly assign the kids to each group. Half here, half there. So true independent variable. Okay, now after they watch 30 minutes of their aggressive cartoon, we set them free on the playground and we look to see who hits who calls somebody else a name, etc., etc., etc. And just like before, so this is not a different experiment, same experiment, I'm just reminding you what we did. We're going to look at the number of aggressive acts that the Winnie the Pooh kids engaged in, and we're going to see a mean number here. And we are going to similarly count the number of aggressive acts that the Tom and Jerry kids commit, and this is their mean. And just like before, we see that the two sample means are different. So if you go back a slide, you will see that nobody's going to dispute why the fact that X bar 1 and X bar 2 are different. All right, we always should expect to see differences between our samples, right? Our the different groups. Why? Because of sampling error. We're always going to have sampling error. So we're always, expecting to see that X bar 1 is going to be different from X bar 2. So up to this point, there's no difference between HO and HA. Where we see HO and HA differ is in their explanation of why the two means are different. Why is X bar 1 different from X bar 2? Now, you learned that with HO, X bar 1 and X bar 2, according to HO, they are different only because of sampling error. But HA is going to say something else. HA is going to say that, yes, there's sampling error, but there's something else. The means are different for more reasons than just sampling error. Something else is going on, and again, we tend to talk about that as a treatment effect, okay? The something else we call a treatment effect. So HA is going to argue this. So HA is going to say, once these kids, the ones watching Winnie the Pooh, once these kids saw 30 minutes of Winnie the Pooh, that did something. It changed them in such a way that they became less aggressive. All right? And those who watched this cartoon, that changed them in such a way that they became more aggressive. All right? So HA is going to argue that these now represent two separate populations. X bar 1 is now representing a new population, a population of Winnie the Poohers, okay, a population of kids watching nonviolent cartoons. So this is, again, X bar 1 is estimating mu1, and mu1 is very specific. Mu1 refers to the population of nonviolent cartoon watchers. However, according to HA then, X bar 2 is an estimate of mu2. And mu2 is the population of violent cartoon watchers. And these two populations are not the same. And that is why we see that is why we see a difference between the two sample means. The reason why these two sample means are different is because of sampling error. We can't get rid of that. But according to HA, it is also because of, quote unquote, something else. Okay? Now, I want to explain one thing before we move on. All right? Because I don't want you to get, I don't want you to misunderstand something. It's actually the researcher is the one who's going to explain what that something else is. So the researcher, if I'm the researcher in this study, I'm going to try and convince you that something else was my manipulation. It was, Winnie the Pooh versus Tom and Jerry, right? That is the something else. That's the treatment effect. That's what made these two distributions different. But in hypothesis testing, when we run a statistical test, those are mathematical formulas. They don't know what Winnie the Pooh means and what Tom and Jerry means. All the statistical test can tell you is that the two sample means are different for reasons other than sampling error. The statistical test will tell you that there's something else going on. It's up to you as the researcher to try and convince everybody that it was your specific manipulation that produced this difference, okay? So this is something that we will explain later as well, okay? So just as a review, HO, null, not a nothing, is going to say that the reason why these two means are different is simply because of sampling error. This sample, this group that watched this cartoon, these boys just happened to be low aggressive boys to begin with. They just ended up in this group by accident. And this sample here, this mean is higher, not because of Tom and Jerry, but because that these boys happen to come from this part of the population. All right, and that means that they were more aggressive to begin with, okay? And so that's why you're seeing a difference between X bar 1 and X bar 2. Has nothing to do with any kind of treatment. It just has to do with sampling error. HA, the way I like to think of this is HA laughs, like get it? Ha, 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 laughs at HO. And HA says, you're wrong. Okay, the reason why these two means are different is because there's more than sampling error going on. It's because there's something else. Now, what that something else is, HA is not going to tell you. It's up to you as the researcher to try and convince your audience that this is the reason why these means were different. That, in other words, this is the something else. Okay? Now, HO and HA never change their minds. HA will never say to HO, oh, you were right, I was wrong, or vice versa. HO is not going to apologize and say, oh, you were right and I was wrong. It's just like lawyers, right? When do you ever hear a lawyer for the defense say, oh, yeah, you guys are right, my client's guilty. Throw away the key, right? That's not much of a defense lawyer. A defense lawyer is going to maintain that his client, is innocent and he just got a bum rap or something like that. And similarly, let's say that the jury finds the defendant innocent. Well, A is never going to say, oh, yeah, you're right. He is innocent. Oops, sorry. All right, you don't hear lawyers switching what they say about their client. So same thing with HO and HA. HO and HA are always going to say the same thing. HO is going to say no, not a nothing, and HA will always say there's something in addition to sampling error. Okay,